students, today we are going to study the practical of determination of strength of hydrochloric acid. So here you can see the aim of practical. In this practical we are going to determine the strength of dilute hydrochloric acid by titrating it against standard solution of sodium carbonate. So we are going to determine the strength of hydrochloric acid using standard solution of sodium carbonate. Here we know the concentration of sodium carbonate. So with the known concentration of sodium carbonate, we are going to find out the unknown concentration of hydrochloric acid. Children, see here the reaction. In reaction, you can see that Na2CO3, that means sodium carbonate, is titrated with HCl. So, on reaction of Na2CO3 with HCl, we get NaCl, CO2 as a side product and H2O as a side product. So, I hope you understand what is the reaction. The reaction is titrating acid and base. Due to titration, there will be formation of salt and water and carbon dioxide will be as a side product. So children, here you can see that there is an unknown solution of HCl, that is, we are not knowing the concentration of this HCl. Then there is Na2CO3, which is 0.1 normal, and indicator, as you know, methyl orange. You can see it is orange in color, therefore it is named as methyl orange. We require pipette, 10 ml of pipette. Then there is a burette, you can see this is a burette, and a flask for reaction. So children, first you always place a funnel. Whenever you are filling the burette, always place the funnel on the burette, and the first step is to wash the burette. So let us first wash the burette and clean the burette. So you can see that we are washing the burette with the help of water. So always wash it and clean the burette. So children, after washing the burette, we will fill it with Na2CO3. So let us fill it with Na2CO3. Always remember to place a funnel. Fill the burette with the help of funnel. So you can see that we are filling the burette with the help of Na2CO3, and now come to the bottom section. Here you can see that there are some air bubbles. So our step is to remove the air bubble. How we can remove the air bubble? Then you can see that by fast opening, there will be removal of air bubble. So here you can see that as we opened out, the air bubble got removed. Now here we will again fill it and make it up to 0 mark. So we will fill up to 0 mark. If there is an excess, then we will remove out by opening. So you can see that by slight opening, we will make it up to 0 mark. So here up to the mark we have filled it up. Now transfer to the flask. So we have transferred the HCl solution to the flask, and to this solution we will add 1 or 2 drops of methyl orange. So you can see that there will be slight yellow in color. You can see the solution which will be yellow in color. After titration, it will change to pinkish red. So now let us titrate it and see the color change. So we will titrate with the help of burette. You can see that drop by drop solution is added to it and there will be a constant stirring. Add till the color changes to pinkish red. So now you can see that there is a change in color and the solution turned to pinkish red. You can see the end point is at near 9 and it is nearby 9.2. So the color change will be this pinkish red. Observe this and repeat the practical for 3 times and mark in the observation table. As I told you that you have to mark in your observation table. So here you can see that this is an observation table. You have to make such table in which there will be one column where you will write like this: burette reading, final reading, initial reading and difference. So this will be one column, and then next you can see that there are such type of marking. One, that is first reading. Second, that means we are performing second time that reading. And third one, that means we are performing third time, and the third time reading we will mark it here. After that there is one, here you can see is constant reading. That means we will check that which reading is constant. Any of the 2 readings should be constant, or sometimes if the reading is not constant, then you can also take average of all 3 readings and mark it down here. We have got a constant reading and so we are marking down as 9.2. Okay, so in this way you will prepare a table where you will write down final reading, you will write down initial reading. Children, initial reading will be always 0 as we are marking up to 0 and then we are performing the practical. So initial reading will be always 0. Final reading will be whatever your burette reading, and when you minus both of them you will get the answer, that is difference. 9.2 minus 0, so you will always get 9.2. So that is the difference. And the last column will be constant reading. The last column will be the constant reading of it. Clear? So in this way there is an observation. Now we will move to the calculation. After observation we will do calculation. What is the formula to calculate? Then you can see the formula here. A1 N1 V1 is equal to A2 N2 V2. Okay? So the formula is A1 N1 V1 equal to A2 N2 V2, where A1 N1 V1 will be for HCl. These terms are totally dedicated for HCl, while A2 N2 V2 are dedicated for Na2CO3. What we have to place in this? Then see here, A1 will be equal to 1. Why? Because we are taking 1 mole of HCl. If you remember the reaction, there was only 1 HCl. So according to reaction, A1 will be equal to 1, A2 will be equal to 2. Why? Because we are taking 2 Na2CO3. If you remember the reaction, then in reaction we had taken 2 Na2CO3. So A2 will be equal to 2, A1 will be equal to 1, then N1 will be normality of HCl. N1 will be normality of HCl, which we are not knowing, which we are going to find out today, and that is our practical. N2 is equal to normality of Na2CO3, which we are knowing, and it is 0.1. V1 is equal to volume of HCl, that is pipette volume. So we had taken 10 ml. V1 will be equal to 10 ml. V2 will be equal to volume of Na2CO3, that is our burette reading, and burette reading was 9.2. So here we will write down burette reading as 9.2. Right? V2 is volume of Na2CO3, and what Therefore, we can say that what is the result? The result is the strength of